Hello, everybody.
Hi, Matrix. So there's a do now on the screen for you to have a look at. It is technically a grade 11 question, but this is the sort of thing that you will be asked in grade 12 as well. I'm hoping that you guys will be able to at least do the first couple of questions, but we'll get underway just now. Anyway, it's nice to have you all with us again. I hope you've got a calculator and a pen. Hi, Acton Corsi. Yeah, calculator, pen, and a book, and that's about it. Who else have we got? Karabo, Silindile, Jaden, Azayo, Swelile, welcome back. Luyanda, nice to have you guys with us. Sayuri, Michaela, Sake, cool. Okay, so Matrix, hopefully you've had a chance to at least read the do now and sort of try and make some connections with what you see. Unfortunately, you know, what is so difficult about teaching geometry online is that, you know, you really kind of need these pictures in front of you so that you are able to draw on them and write on them as well. But anyway, we'll do our very best to sort of try and make it as interactive as possible. Please don't be shy. I don't mind if you ask me something 10 times over. I'm happy to explain it to you. And no one's judging you. This is a safe space and all questions are welcome. We're all here to learn. We're all here to help one another. So yeah, please interact and don't be shy to ask questions or to discuss things or to ask more about something. It's absolutely no problem at all. Geometry is a notoriously difficult section. Before we actually get underway and we start talking about proving that things are cyclic quads and angles that are equal to x and whatever, I just want to get a feeling for how you feel about Euclidean geometry. So in the chat, if you could either post a thumbs up or a thumbs down. I don't know, what could we use for, you don't really have one opinion one way or another. Let's just see what emojis we've got here. Okay, well, there's a thumbs down. Okay, well, there's an emoji, an expressionless emoji. So if you have no feelings about it, then you can use the expressionless emoji. I just want to get a feeling for what you guys think. Okay, so Michaela says no. Swelithle says okay. Ayomide says no. Try that again, Franklin. Silindile says no. Okay. And the rest of you, Luyanda? Sake, Chad says no. Okay, Luyanda's happy. Karabo? Deneo. Okay. It's in Corsi. Okay. Oh, Karabo. Okay, guys. Thank you. Thank you very much. It just gives me an idea of where you're at. And unfortunately for us, geometry is one of the biggest sections, isn't it? This year they've changed things a little bit. Normally geometry is worth 50 marks, and then 25 of it is grade 11 geometry, and the other 25 is matric geometry. But I think this year, I stand to be corrected, but I think this year they've actually dropped that down to 40. But still, 40 marks out of 150 is still a lot of marks. All right, so let's see what we can do. Now, as far as grade 11 geometry is concerned, that's super important, because what they start doing eventually is that they start linking the grade 11 and the grade 12 questions together. So you actually can't separate them. But the first one here is just very definitely a grade 11 question. So everything to do with circles. The first thing that we have to do when we're doing geometry grade 12s is we need to read the information. Okay, you have to read the information first and then look at the picture. I can't tell you how many times I've made the mistake of ignoring the information, looking at the picture, and then sitting there and not being able to answer the question. I've done it myself. So always read first. So it tells us in the figure below, we've got RQ and RB that are tangents. Okay, so now we hear the word tangent. So either unmute your mic or type in the chat, what does the word tangent bring to mind? What do you start thinking of? What theorems are associated with the word tangent? Tan chord, cool, Timothy, 100% tan chord, lovely. Radius tan theorem. Okay, so the radius perpendicular to the tangent. Yes, lovely, very nice. Tangents from the same point. Excellent, guys. Good, absolutely. And we've got all of those going. We've got all of those going on here. So excellent. I'm really, really pleased to see that you wrote that. Nice. So tangents. So Q is a point of tangency and B is a point of tangency. Circle center O, the radius BO produced to A, to P, and then they've said to us, let Q1 be X. All right, so I'm going to write that in red. Okay. First thing that they want us to do is they want us to prove that RBOQ is a cyclic quad. So what I would recommend is when they ask you to prove that something is a cyclic quad, or they're asking you to prove the triangles are similar, or whatever it is, try and highlight the shape. Highlighters are your best friend in geometry, I believe. So what I'm going to do is I'm just going to take the yellow and I'm going to highlight R. Ooh, hopefully not very well. Long lines are difficult to highlight. Okay, but there we go. More or less. All right, there we go. We've highlighted RBOQ. They want us to prove that it's a cyclic quad. Now, someone has already said something that's going to help us to be able to do it. It's in the chat. Someone said something. And it's actually Sake. Have a look at what Sake said. She said tan radius theorem. In other words, the radius is perpendicular to any tangent. So I would like someone to tell me, where can I find a 90-degree corner on the inside of the cyclic quad that I've highlighted? Can anybody tell me what angles would make 90 degrees? You can unmute your mic or type Q4. Good start, Chad, but not just Q4 on its own. It's Q4 and, but you're looking in the right place. Q4 and, there's two angles together. B2, not together, no, you're looking, Shay, you really are looking in the right place. Okay, so Q4 and Q3, there we go, Luyanda. Perfect. All right. So Chad, this is what we're trying to look at over here. All right. This line OQ, B2 and B3. Do you mean B1 and B2? Jaden, B1 and B2? Okay. Yes, B1 and B2. Okay. So OQ is a radius. The radius is perpendicular to the tangent. Quite right, Jaden. B1 and B2. RB is a tangent, OB is a radius, and the radius is perpendicular to the tangent. So what we've been able to do here, Matrix, is we've been able to show that there are two opposite corners of this cyclic quad that add up to 180 degrees. Okay, so we can prove that our quad is indeed cyclic using converse opposite angles of a cyclic quad are supplementary. Okay, this is how we're going to set it out. So first things first, what Luyanda said and what Chad was telling me as well. Okay, so Q3, so let's just write A, Q3 plus Q4 equals 90. Radius perpendicular to tangent. Okay, now Jaden, what you had said, B1 plus B2 adds up to 90. Same reason, radius perpendicular to tangent. Therefore, RBOQ is cyclic. Reason, converse, opposite angles of cyclic quad are supplementary. What does the word supplementary mean? Additional? Yes, there we go. Adds up to 180. Absolutely. Absolutely. Very good. In fact, I suppose what I could have done to be good, guys. Now, that's excellent. 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 Suppose what I could have done here, let me just put it in a different color. Not that we would lose any marks for this, I don't think, but let me just put it in pink. So in other words, if we add together, so therefore Q3 plus Q4 plus B1 plus B2 adds up to 180. Okay, so because it added up to 180, it makes it a cyclic quad. Is everybody okay with that? Is there any questions? Sure. Is there another way? Timothy, what a good question. What a good question. If you want to prove, let me ask you, let me return your question with a question, okay? Timothy, if you want to prove that a quad is cyclic, how many ways are there to do it? Okay, so Karabo says 4, Timothy says not sure, okay? There are 3 ways, okay, that you can prove that a quad is cyclic, all right? Just 3. Yes, Benedict, there we go. Benedict, since you said 3, can you name them for me? Can you name them, Benedict? And this is a question you're always going to be asked, Matrix. Anybody else know? Anybody want to hazard a guess? Okay, perfect. Okay, so this is the first one. Okay, so converse, opposite angles of cyclic quad are supplementary, and we can use the word cyclic because we've used the word converse. There we go, Timothy, very nice. Okay, so opposite exterior angle of a cyclic quad. So yes, so the way that we say that is converse exterior angle of cyclic quad. Good, Timothy. All right, now there's just one more. There we go, Swelihle, bang on, well done. Okay, converse angles in the same segment. I'm really impressed. Well done. So for people who really said that you don't like geometry, so far, you guys know a lot. Ma'am, what is the definition of a converse? Luyanda, excellent question. A converse is an opposite. Okay, so let me give you a very basic explanation. All right. Do you remember back in grade 8, grade 9, we learned about the theorem of Pythagoras? All right. And what was given to us was that the triangle was right angled. Because the triangle is right angled, adjacent side squared plus adjacent side squared equals hypotenuse squared. Okay, so we could make that statement. So all of us come along and we say, in this case, so I'm just a very badly drawn triangle. Let's call that A, let's call that B, let's call that C, and it comes with a right angle. All right, so we're able to say that B squared plus C squared equals A squared, and the reason for that is the theorem of Pythagoras. Now, let me show you something else. Let's get a different color. Here is a triangle. The length of this side is 5. The length of this side is 3. The length of that side is 4. Okay, let's call this triangle ABC. And the question is triangle ABC right angled? So Luyanda and everybody else, this is what we would have to do. We'd have to take the 2 shorter sides, the 2 sides that would be adjacent what we think is going to be the 90-degree corner, which we suspect is at C, but they haven't told us that. And And we're going to add them, we're going to square them and we're going to add them together, right? So we're going to say 3 squared plus 4 squared. And that's going to give us 9 plus 16, which leaves us with 25. Then we're going to take the side that we think would be the hypotenuse, the longest side, in a totally separate calculation, and it's 25. So what we have found here, what we found is that AC squared plus CB squared equals AB squared. That's what we've discovered, isn't it? So therefore, triangle ABC is right angled. Reason, converse theorem of Pythagoras. So that's what a converse is, Luyanda. It's a way of working backwards. So if a quad is cyclic, it possesses certain qualities, all right, that we are allowed to assume and use. So in other words, the opposite angles are supplementary, or the exterior angle is equal to the opposite interior angle. But if we do not know if a quad is cyclic, we have to use other methods to prove that it's cyclic, that it has these particular qualities. All right, so that is a converse. All right, so a converse allows us to work backwards and go the other way. Is it compulsory to give a reason? Yes, it is. It is. You have to. If you've proved that a triangle is right angled using the converse of the theorem of Pythagoras, you absolutely have to write it. And it's the same with proving that a quad is cyclic. You absolutely have to write these reasons. Okay, otherwise you won't get the mark. Okay, so, but this is something that you have to learn, guys. All right, now, if we have a look, now going back to what Timothy said, is there another way for us to be able to do this? When we do converse angles in the same segment, there has to be a bow tie inside the cyclic quad for that to happen. So in this particular case, there is a bow tie inside. Do you know what I mean when I say a bow tie, Matrix? You know what I mean when I say a bow tie? So I'm going to, yes, okay, there's a bow tie inside. Butterfly angles. Oh, what a nice way of putting that. I've never heard of that before. Yes. Okay, so here's my bow tie. Come now. Angles in the same segment, exactly. All right, so you can only get angles in the same segment if there's a bow tie on the inside. All right, so whoopsie daisy. There we go. There's the bow tie. I am gonna rub those out because that's horrible. Okay, so if I was able to prove that that angle, for example, equaled that angle, then I could also prove that the quad was cyclic. But I don't think, Timothy, that I had enough information with regards to this diagram to be able to do it using converse angles in the same segment. I think in this case, this is the only way that we would have been able to do it. Oh, you know what else we could have done? Hang on a second, Benedict, I'm going to answer your question now. Timothy, you know what else we could have done here? We could have done converse opposite angle, no, converse exterior angle of a cyclic quad. We could have done it that way as well. Do you want me to show you quickly? So in this particular question, we could have done it that way too. What we would have done in this case, let me just get rid of this X here, is this. Okay, so No, I think it's so important for us to discuss how we can do things differently. It's one of the most important discussions we can have in math. And Benedict, I promise I will answer your question. Okay, if I move on and I don't, remind me, but I promise you I will. Okay, so the other thing that we could do is we could say that that angle over there is 90 degrees. Okay, that is the exterior angle of the cyclic quad. All right, so the side of the cyclic quad, in this case, it's called RQ. RQ has been extended to P, which means that Q1 and Q2 are the exterior angle. Okay, so what I could do is I could say this is my alternative. I could say that Q1 plus Q2 equals 90, again, because the radius is perpendicular to the tangent. Then I could go over here and I could say that's going to be 90 like I did before. Let's say B1 plus B2 is equal to 90. Again, radius perpendicular to tangent. Okay. Therefore, angle OQP equals angle OBR, because they're both equal 90. Therefore, RBOQ is cyclic. Reason. Converse. Exterior angle of cyclic quad. Okay, so we could have done this first question, we could have done it in two ways. All right, okay, Timothy. I hope that makes sense to you. All right, now Benedict, back to what you were saying. It's a pleasure, Timothy. Don't all angles have to touch the circle? Benedict, what do you mean exactly by that when you say don't all angles have to touch the circle? Are you talking about angles in the same segment? Yeah, okay, so for angles in the same segment, all right, if you have proved that a quad is cyclic, like we have in this case, then what you will find is that some of the angles will not be at the circle. So in other words, angle Q3 equals angle R2. R2 is not at a circle that's drawn, okay? But yes, essentially that is going to be what happens, because once you prove that the quad is cyclic, what you've done really, Benedict, is that you've proved that it's possible to draw a circle through all 4 points. So yes, essentially they will be at the circle, even if the circle is not drawn. Okay, does that answer your question? Cool beans. All right. Okay, so on to the next thing. All right, they've asked us to find out some other angles that are equal to x, all right? And they've said here, I'm going to put my x back. They've said that angle Q1 is equal to x. Okay, so I'm going to call on, who am I going to pick on? Karabo. I'm going to pick on you. Well, not really pick, but you know what I mean. Karabo, can you give us another angle that is equal to x, please? With a reason.
I would say that x is equal to b2 because 10 chord.
Why b2, Karabo?
When I put it this way, the angle b2.
You're very close. You're very close, Karabo, but it's not b2. It's actually b1.
Oh, okay.
B1.
Oh.
Okay. All right.
Okay.
Well done. Okay. So B1 is correct. So here we can see PQ is the tangent, AQ is the chord. Okay, so what I want you, well, I know it's a bit difficult for you to do this, but you would put your fingers at A and at Q, and then you would follow your way down to the circle, and then it would be B1. Okay, so let's just get some more space here. We've proved that the quad is cyclic, and hopefully you guys have written that all down now. Okay, so Karabo says angle.
Ma'am?
Yes, Jaden.
Doesn't that mean that x is also O1 is also equal to x?
For what reason would O1 be equal to x, Jaden?
Oh no, sorry. I saw the wrong thing. Oh,
it's okay, Jaden. Do you know what you've done though? And it's a very, very common mistake. Is O1 is at the circle, is at the center. Okay, so a tan chord only works when the angle between the tangent and the chord is equal to the angle in the alternate segment, and the angle in the alternate segment has to be at the circle. Okay, but I'm really glad you asked, Jaden. Okay, I'm really, really glad you asked. Okay, so far we've got B1 equals X, and our reason, guys, was tan chord theorem. All right. So now we've got to think of a few others. Anybody see anything else going on here? Michaela, can you see another angle? Okay, Chad has said something. Okay, so Chad says Q3 equals B1. Excellent, Chad. Why? Why? Very nice. I'm so pleased. Okay, so I'm writing that down, okay, Chad, but I want you to tell us the reason. Can anyone help Chad with the reason, unless not sure on the reason? Cool. Okay, but OQ, yes.
Ma'am, isn't it because OQ and OB are both radii and they create an isosceles triangle and the base angles are equal?
Beautiful, Luanda. Wonderful. Okay, exactly. So the way how we say that is we say angles opposite equal sides. Okay, angles opposite equal sides. Excellent, very nice. Okay, well, for a group of matrics who said you hated geometry and it wasn't your strong suit, you're working very well together, and we certainly are getting somewhere. Okay, so now we've named two. What else, guys? What else? Where else is there an angle that's equal to x? Remember, you've proved RBOQ is cyclic. Hint, hint, hint. So if you've proved that RBOQ is cyclic, yes.
Can't R2 also be equal to X because of angles on the same segment?
Can R2 be equal to X? Okay, so now you've got exactly, R2. Nice one, well done. R2 equals X. Angles in the same segment. You've got it. Brilliant. So this one over here, and then one more. We just need one more, please. It's actually the same thing. It's angles in the same segment. All right, so R1. Indeed, Jaden. R1 as well. Perfect. Okay, so R1 is equal to X, also angles in the same segment. Okay, so R2 is equal to X, angles in the same segment, because R2 and Q3 are angles in the same segment. Okay, I'll say that again. R2 and Q3 are angles in the same segment. With R1, okay, it was B1 and R1 that were angles in the same segment. Okay, very good. Well done. So there's 4 angles equal to X. Good, guys. There we go. We've smashed that, A and B. Now, last thing, express P in terms of X. All right, so P is this angle up here. And they want us to express it in terms of X. All right, so we've sort of got to look at the position of P. P is inside triangle AQP, and we already know that Q1 is equal to X, but we don't know how big A1 is. All right, so let's try and look a little bit bigger. Okay, it's also in.
I don't know if I'm going to make sense now, but is AB a diameter?
It is indeed.
So then Q2 and Q3 make up 90, right?
Correct, they do.
No, never mind, ma'am.
No,
I don't know what I'm trying to say. Because I was thinking that if that's going to be a 90, and then having Q3 as an X, and then B1 as an X also, I don't know. No, never mind, ma'am.
No, you're not wrong. You're not wrong at all. You're not wrong at all. Okay, you actually can do that. You can do that.
Oh.
Okay, you're not wrong. You're not wrong. Look here. This is the triangle that you are working in. All right, I'm going to try and highlight it for you, and let's use yellow again. Okay, so we've got QB. Then we've got BP. And then we've got PQ. Can the rest of you see that? Okay. So 100%, Swelile, you didn't say anything wrong there at all. It was excellent, all right? So the 3 interior angles that are making up this triangle is angle P, angle PQB, which is this big angle over here, and then angle B1 down there. The angles of a triangle add up to 180 degrees. So let's say this. Let me just clear a little bit of space here for us to write. Okay. So Swelile, can you remember the reason why angle Q2 plus Q3, why would it be equal to 90? What's the reason for that?
Angles in semicircle.
Hey, wonderful. Okay, you guys are amazing. Cool beans. Okay, so Swelile, Q3, Q2 plus Q3 equals 90.
Yes, ma'am.
Okay. Angle in a semicircle. Okay, so now when we say P plus X is going to be Q1 plus 90 is Q2 and Q3. So that's this entire angle over here that I'm coloring in yellow, plus X, that's now at B, equals 180. Angle, sum, and triangle. The interior angles of a triangle sum up to 180 degrees. So leaving P on its own on one side, taking everything over to the other side, P is going to be equal to 90 minus 2x. How does that feel, Matrix? Well done, Swelile, you cracked it.
Thank you, ma'am.
Well done. Okay, how's everybody feeling now? So in the beginning, we were a bit thumbs downs. How are you feeling now? Thumbs up? Still sort of iffy? Is there anything you want to ask me? Give me some emojis. Tell me how you feel. Cool, Leander. That's nice, Timothy. Thank you. Okay, well, I hope that the rest of you are feeling as good as Timothy. Okay, Benedict, all right, that's fine. Not a problem, Benedict. This is a difficult section. We're going to try and just do the best that we can. Okay, Rekomodetswe, that's fine. Okay, keep asking questions. If there's anything that I say that doesn't make sense to you, then I want you to ask me. This is Lindy. Okay. That's fine. Okay, so yeah, please, all of you that are not 100% sure, keep asking questions. So at Nkosi, oh, you feeling sad? I'm sorry. I know this is a particularly difficult section, but we're going to try and go as slowly as we can. All right. So before we start proportionality intercept theorem, or before I teach it to my matrix, I always start off like this, and I say to them, well, what is a proportion actually? And I think that's really important to establish what a proportion is before we can talk about proportionality intercept theorem. And a proportion matrix is a statement that two ratios are equal. So in other words, if we look at it like this, okay, Luke and Jack are both eating pizza. Luke has had his pizza cut into quarters, but Jack has had his cut into eighths. Luke has eaten 2 out of his 4 slices, and Jack has eaten 4 out of his 8 slices. The quantity eaten in both boxes is the same. They've both eaten half their pizza. Therefore, the ratio of pizza that's been consumed is equal. In other words, 2/4 is 4/8. That matrix is a proportion. Okay, so specifically this relationship where a fraction equals a fraction, that is called a proportion. All right, so very important that you know that. So now if we consider the proportion, A over B equals C over D, right? There are some very important manipulations that we are allowed to make based on this, okay? So what I'm going to do, in addition to using the A's and the B's and the C's and the D's, I'm going to do this with numbers so that it makes sense to you. Okay, so in number 1, what they're trying to do, what they're trying to say to you is this. Okay, can you see they've put the denominator at the top and the numerator at the bottom? So they've switched the place of the numerator and the denominator. So in other words, what they've done is this. If I say to you, if 1/2 is equal to 3/6, I've written a proportion. But then it's true, number 1 is saying, well, 2/1 is equal to 6/3. So if I invert the one side, I can invert the other side. In part number 2, they're talking about the ratio of the numerators, okay, compared to, is equal to the ratio of the denominators, all right? So again, if we use our numbers, all right, so remember we've said before, or what we're working with is that A is being represented by 1, B is being represented by 2, C is being represented by 3, and D is being represented by 6. So what we are saying is this, all right? If I take 1/3, it's the same as 2 over 6. Does that make sense to everybody? Okay, so what I've done is I've changed places. The 3 and the 2 changed places with one another. How does that feel, everybody? Is it making sense? Then another thing that I'm allowed to do is I'm allowed to cross multiply. All right, so if I've got 1 over 2 equals 3 over 6, when I cross multiply, let's do that in purple, I say 6 times 1, so 1 times 6 is equal to 2 times 3. Okay, so that's why I'm allowed to cross multiply. That's why I'm allowed to write AD equals BC. Okay, because I've cross multiplied. Then in question number 4 and in question number 5, they're showing you how to make one of the values the subject of the formula. All right, so if we have a look over here in number 4, right? So if I have got 1 over 2 equals 3 over 6, I can make 1 the subject of the formula by multiplying 2 with 3. So in other words, I'm saying 1 is 2 times 3 over 6, which is true, isn't it? Or if I wanted to, I could make the 3 the subject of the formula. Okay, so if I've got 1 over 2 is 3 over 6. Now I want to make 3 the subject of the formula. So now I'm going to cross multiply as well. So now I've got 1 times 6 over 2 equals 3. All right, does that make sense? Can you see why these are equal to one another? All right. And then I don't want us to worry too much this evening about these ones over here. These are a little bit more difficult, but all they're really trying to say is that, again, using our numbers, if I take, so for number 6, if I take 1 and I say 1 over 1 plus 2 is going to be the same as 3 over 3 plus 6. Okay, so that's going to give me 1 over 3, because what it's equal to is 1 over 3 is equal to 3 over 9. Okay, so the numerator divided by the sum of parts on both sides. Okay, and then in number 7, it would be the same idea. So what we could do is we could work with the denominator. So in other words, if we put 2 at the top, 2 over 1 plus 2 is going to be the same as 6 over 3 plus 6. Okay, because that's going to give us 2 over 3, which is the same as 6 over 9. Okay, so we can make all these different kinds of manipulations when we are working with the ratios and the lengths of sides. How does everybody feel about that? Are we all good? Are you horrified? Happy? It does. It makes more sense when you use numbers. Exactly. That's why I'm doing it that way. All right. Okay. So, Sabahle, what we are basically trying to do, I'm going to go through it again with you. But what we're basically trying to do is we're just manipulating. All right, we're just showing how we can rewrite, we can take our proportion statement and we can rewrite it and we can manipulate it and do different things with it. Okay, let's have a look at 1, 2, and 3 here, Spahle, and then let's see how you feel after that. Okay, so let's just look at these questions here. Okay, so first point, PQ is 135 centimeters long. R is a point on PQ such that PR is to RQ is 7 is to 2. Calculate the length of PR. Okay, so I think a nice way of us being able to visualize a problem like this is as follows. Okay, draw yourselves a diagram matrix. Okay, so here in number 1, let's draw a line. There's P, there's Q. They've told us that R is a point on PQ, such that PR is to RQ is 7 is to 2. They've then told us that the whole of PQ is 135 centimeters long, all right? They want us to calculate the length of PR. All right, so in other words, from here to here. If we add the ratios of the sides together, all right, so from here to here, 7,105. Yes, we're perfect. Okay, do you want to tell us how you did that? Good girl, well done. Can you unmute your mic, or is it not possible?
Ma'am, can you hear me?
I can hear you.
Okay, so I took the 135 and multiplied by 7/9 because 7 plus 9 plus 2 is equals to 9.
Excellent, 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 excellent. 100%. Okay, so what Rekomoditswe did for the rest of you is she added 7 and 2 together. She said that PQ has been cut into ninths. PR is 7 of those ninths. So there's 2 ways. Again, there's more than one way to do these sorts of questions. Rekomoditswe said 7/9 times 135 gives us 105 centimeters. Nothing wrong with that. Or if you wanted to do it another way, you could have said 135 divided by 9 and then multiplied by 7, and you would have also got 105. Okay, good job. Well done. Next question. All right, so point B lies on AC such that AB over BC is 3/4. If AB is 48 millimeters, calculate the length of BC. So what do we need to do here? We've been given a proportion. I'm just going to rub, can I rub this out, the purple? So we've got space to write. We've been given a proportion. Okay, here's our proportion matrix. Now they've given us this. So how about we take that and we substitute. Calculate the length of BC means this is what we're going to solve for. All right, so in number 2, we've got AB over BC equals 3/4. Do you remember in the beginning, we had said that it was okay for us to invert things? So if I want to, I could say that BC over AB is equal to what over what? You're quite right. I think it is 64. Yes. Good, Sparkle. There we go. Nice. Excellent. Okay. Okay, is going to be equal to 4/3. So, Sparkle, Yes, indeed, a CP, quite right. Now, the reason that I decided to invert this is because I think, this is just my own belief matrix, it's up to you. But when you put the unknown, so in other words, what you are looking for in the numerator of the first fraction, it just makes it easier to solve. Can't you just cross multiply? Absolutely, Benedict. Absolutely, you're going to be, it's exactly what you're going to do. So I'm going to get rid of the AB. I'm going to substitute in the 48. Okay, exactly. So Benedict, 3 times BC is 3BC. 4 times 48 is how much? 192, isn't it? Divide both sides by 3, and that means that BC would be equal to 64, just as Sibahle said. Okay, well done, Matrix. That looks really good. What I'm thinking is maybe instead of us doing number 3 and number 4, again, just us cross multiplying and substituting whatever, maybe what we should do, since we've got like an hour and 5 minutes left, is maybe move into the proportionality intercept theorem, okay? Because you seem to know what's going on here, and I'm sure you'll stop me and ask if you don't. All right, so the proportionality intercept theorem says a line drawn parallel to one side of a triangle divides the other 2 sides proportionally. Okay, so here in this diagram matrix, PQ. Okay, that's fine, Ayomida. You just catch up on YouTube and then you can watch it later. No problem at all. All right, so here we've got line PQ. It is the line that's drawn parallel to one side of the triangle, so in other words, to BC, and it cuts the other 2 sides into the same proportion. So in other words, it cuts AP and PB into the same proportion as AQ and QC, the same proportion, not the same length, but the same proportion. And there's our conclusion. Okay, so AP over PB is AQ over QC. There's our proportion. And when we make a statement about a proportion matrix, we have to write proportionality intercept theorem as our reason. Now, you are allowed to abbreviate that. I don't teach this at my school, so line parallel to one side of triangle, but if you want to use that reason, there is nothing wrong with it, and you will get full marks. I always use this, and then we abbreviate it. So we write it like this: prop int theorem. Just like that, and then you've got to remember to name the parallel lines. Matrix, if you use prop int theorem and you don't name the parallel lines, they will take the mark away from you for the reason. Okay, so very, very, very important. Don't forget to name the parallel lines. Okay, so that's proportionality intercept theorem in a nutshell. Okay, so let's have a look at this, and you're going to give me the answers over here. All right, so can you see XY is drawn parallel to QR? That means that PX over XQ is the same as PY over YR. All right, so now I'm going to call on Azayo. Azayo, PY over YR is equal to what? PY over YR in this diagram is equal to what over what? We're completing the proportions. Excellent, excellent. So PX over XQ. Good job, well done. Okay, next one. Let's just see who we can. Deneo. So QX over XP. So QX over XP, Deneo, is going to be equal to what over what? ry over yp. Excellent. Good job. Okay, Chad 3.3. Let's see you do this one. So something over yr so something over yr equals something over py. So again, this comes from one of our proportions in the beginning where we can compare, we can put the numerators in proportion, or we can put the denominators in proportion. Yeah, this is a little bit of a difficult one, isn't it? Okay, so this is xq. Okay, so xq over yr is the same as px over py. Yeah, it's okay, Chad. That I did give you a difficult one there. All right, but again, an important conclusion for you guys. Okay, so guys, xq over yr is the same as px over py. All right, 3.4, let's ask Jaden. Py over pr is the same as what? So py over pr is the same as? What do you reckon, Jaden?
XP over PQ.
XP over PQ. Good, Jaden. Well done. Very nice. Excellent. Okay, so this bit over the whole side is equal to that bit there over the whole side. Well done. Okay, so this was like manipulation 6 and 7. All right, where we were adding the two together. Excellent. Well done, Jaden. You guys are doing so nicely. I'm so impressed. You said that your geometry was terrible, but it really, really isn't. Okay, that's great. Sayuri. Why don't you try 3.5? Okay, so PQ over XQ. PQ over XQ is going to be the same as? So Sayuri says PR over YR. Excellent, Sayuri. Nice. Good job. Excellent. I'm so impressed. Okay. And last one. And I'm going to ask Sake. So Sake, the last one belongs to you. Number 3.6. So PQ over what is the same as what over PY? So PQ over what?
PQ over PR.
PQ over P, well, I'm going to write it in there. Okay, so PQ over PR is equal to?
XQ over, no, PX over PY.
Okay, so let's have a look at what you've said. You've said PQ over PR is the same as PX over PY. Yeah. That's fine, absolutely. And you know what else you could have said here? There's actually another answer here with this one as well. You could have said that PQ over PX is the same as PR over PY. That would have also been true. PQ over PX. Yeah, absolutely. Okay, nice. Well done. All right, so let's jump into some more difficult questions. All right, so here we go. Right, so the first sort of official question. So they've told us in the figure, AB is equal to 12, FB is equal to 3. So let's pop that in there. GC is equal to 14. And we know that AB, the whole side over there, is equal to 12. All right, they want us to calculate the length of AG. So that's this bit over here. Okay, so what do you guys think we should do? First of all, is there something that we can work out before we go any further? I mean, if we know that FB is 3 and we know that AB is 12, what does that tell us about AF? What's AF going to be? That's it, Spartle. Yes, Chad, it's going to be 9. Good. Okay, lovely. All right. Very good. So now we need to make a proportion using the information that we've got and calculating AG. All right. So what I would do in this, because it's obviously quite a simple question, is I would put AG in the numerator of the first fraction. All right. So let's ask, who have I not picked on for a while? Let's have a look here. Okay, Karabo, I'm going to try to see what happens, okay? If you don't get it right, it is not the end of the world, but just go for it, okay? So Karabo, write us or tell us a proportion.
Okay, ma'am. I'd say, so we're looking for AG, so I'd say AG over GC. And then I'd say AF over FB.
Okay, so Karabo says AG over GC is equal to AF over FB. Perfect, Karabo. What's the reason?
Line proportional.
Line parallel.
Yeah,
line parallel to one side of triangle. Absolutely. Okay. Or you can write proportionality, intercept theorem, and then if you do, don't forget to name the parallel lines. So FG parallel. That's it indeed. Okay. And now we can go ahead and substitute. Okay. So AG
over 14.
Over 14, good.
And 9. 9 over 3.
9 over 3. And now what are we going to do? We're going to
cross multiply.
You've got it. All right. And we're going to make AG the subject of the formula. Okay. AG is equal to 42, says Rechumoditswe. Beautiful, Rechumoditswe. Well done. Okay. And very nice. Work from you too, Karabo. Okay, good stuff. Okay, so guys, we would have a mark for our statement, a mark for our reason, and then a mark for our answer. Okay, lekker. Let's move on since you guys are so good. All right, can I give you an opportunity to, and there's a little mistake here. Okay, that's supposed to be X. Okay, so we need to calculate X in the first one. again, I'm going to ask somebody. Okay, so Silindile, I'm going to ask you, can you help us solve X in question number 1? What should we do?
I would say PS over SQ is equal to PT over TR, which is going to be 5 over 2 equals to 10 over X. And then we cross multiply 5X equals to 10T. Then we divide by 5. And X is 4.
Beautiful. Okay. What's the only thing that you left off, Silindile?
Prop inter theorem.
That's it. Okay, but very good. Okay, so prop inter theorem. Good. Well done. That was beautiful. Really, really lovely work. Nice. QR. Okay, cool. So are these ones a little bit too easy? Do we need to do something that's a little bit more difficult? How do you feel? Matrix, should we go to some questions that are a little bit more difficult than these ones? Thumbs up for yes, thumbs down for no. Thanks, Rekomoditswe. Yes. Okay. Cool. Thanks, Sake. Thanks, Chad. Thanks for everybody's feedback. That's great. All right, so now things start to get a little bit more interesting, okay? We're working in one triangle and it was fine. Now, we're going to be working in more than one triangle, okay? So the idea is, before you get started, is to try and identify the triangles that you could possibly work in and apply proportionality intercept theorem to. So they've told us ED parallel to BC and EC parallel to FD. They've also told us that AD over DC is 5:4. So let's just put that in. So 5:4. And then they've told us that AF is equal to 3x minus 5 units. So that's this bit over here. And FE, which is this little one over there, that is equal to 2x units. So I suppose if we wanted to, we could call that one 5y and we could call that one 4y. All right. What do they want us to do? They want us to calculate the length of EB. All right. So matrix, that's this bit down here. Okay. So a little bit more complicated. There's so many lines. Where do we start? Starting place. Which triangles are we allowed to work in? All right. So I would like you to first tell me the names of the two triangles in which we are allowed to work. Or apply proportion. Say that again, Sparkle.
ACE. Triangle
ACE. Triangle ACE. Good, Sparkly, that's right. Well done. Okay, so Jaden said the same thing. And Slindile said AED. AED. Not AED, unfortunately, Slindile, because we haven't got one side drawn parallel to the third side of the triangle. ABC, says Jaden. That's right, ABC. Okay. Excellent, well done. All right, so we can work in triangle AEC because we've got FD parallel to EC. And then the other thing that we can do is we can work in triangle ABC, like Jaden said, because in triangle ABC, we've got side ED parallel to side BC. Okay, so now we obviously need to try and make a proportion based on the information that we've got. All right. What else have they given us? Nothing else. Okay, so that's all the information that we've got. All right, so where is our starting point? What can we do? Can we start with triangle ACE or should we start with triangle ABC? What do you think? Where should we start? We don't know enough about triangle ABC to start there. Unfortunately, not because EB is part of triangle ABC, all right? And we've got X and we've got Y, all right? So we have too many unknowns in order to be able to work out AB. So we're going to start with AEC. Okay, good. Yes. So in triangle AEC, I like to write it. You don't have to write it, but in triangle AEC, let's make a proportion with some of the information that we've been given. Okay, so I'm going to get, okay, Sibahle, make a proportion for me in triangle AEC.
And triangle ACE, ma'am.
Yes, please.
Okay, AF.
Okay, perfect. AF.
Over FE.
Yes. Uh-huh.
Is equal to AD over AC. Over DC, sorry.
Over DC. Good. Well done. Well done, Spatley. That's perfect. Okay, and then once you make your proportion, write your reason. Proportionality, intercept theorem, and FD parallel to EC. Good.
FD
Now substitute, Spatley.
Okay. It's
good. You're doing
3x
well.
minus 5
3x minus 5.
over 2x.
Yes.
Is equal to 5y over 4y.
Good. Well done. Well done. Well done. That's very nice. Okay, and then the y's will cancel out because y divided by y is 1. And now what are we going to do, Matrix? We're going to
cross multiply.
Cross multiply. Absolutely. So that means that we now have 4 times 3x minus 5 equal to 2x times 5. And then we're able to solve for x. Okay, so let's do that now. And then you can pop what you think x is into the chat for me as soon as you've worked it out. Yes, Samara, well done, 10. Yes, Michaela, well done. Nice, good job. I get the same thing. All right, yes, Nala. Yes, Silindile, good job. Yes, Benedict. Nice, well done, Matrix. That's very good. Very, very, very good. Okay, so now that we know that x is 10, we actually know what AF is and what FE is. So let's just rub that out. We know that this is now actually going to be 2 times x, so 2 times 10. So this is 20, isn't it? And then here, 3 times 10 is 30. Take away 5, leaves us with 25. Okay, so we know that AF is 25. Okay, so now, Benedict, we're almost there. Now we need to work out EB. All right, so what do you think we should do now, Benedict, to work out EB? Which triangle do you think we should work in? Quite right. Triangle ABC. Yes, Chad. Yes, Benedict. Okay, so Chad, go for it. Make us a proportion to help us solve EB. What should we write? Okay, so Chad says AE over EB. I agree with you, Chad, is equal to AD, good, over DC. Excellent. Reason? Proportionality, intercept theorem. Okay, ED parallel to BC. Nice, Chad. Well done. Okay, Benedict, take over. Substitute. What's AE equal to? Benedict? How would I get AE matrix? I need to add together which two values? 25 and 20. Okay, so Benedict, yes, 45 is quite right, Karaba and Makeda. All right, so AE, Benedict, is this bit over here. There's AE. Okay, remember up to there was 25 and up to there was another 20. Okay, so it's going to be, you saying it's equal to 36? Yes, Timothy, perfect, you've got it. That's exactly the right answer. Okay, so let's finish this off. Good job. So we have 45 over EB is equal to 5 over 4. All right, so AD over DC. Cross multiply. So that's going to leave us with 5 EB is equal to 45 times 4, which is what, 180. And divide both sides by 5, which means that EB will be exactly as you said. Yes, Samara, quite right. It will be equal to 36. Do you see where we got the 36 from, Benedict? Okay, so writing our proportion, so our statement, our reason, substitute, manipulate by cross multiplying or doing whatever we need to do, and then getting the answer. Okay, good job. Well done. Okay, so let's do a difficult one now. Okay. Right, let's have a look at number 4. Okay, so in triangle ACF, AF parallel to BG, and in triangle CEF, EF parallel to DG. Okay, let's fill in some information here. So ED is 22. DC is 33. BC is 15. And AB is X. Okay, so what do you reckon, Matrix? How are we going to solve this problem? We've got two triangles now. What do you think we should do? Anyone got any ideas? I mean, if I wanted to make a proportion, right? So if I wanted to say something like AB over BC, what would AB over BC be equal to?
FC over GC.
Okay, so it would be equal to FG over GC. Very good. Reason, proportionality, intercept theorem. And that's because FA is parallel to GB. Good job. Okay. Now what?
Ma'am.
What do you think, Nala?
Because FC is a common in both
Good.
CFE and CAF, would you say that CA and CE are equal because CA and FC would be equal because FC is the common?
Nala, you are 100% correct. What you need to do is this, all right? So we've got to say that ED over DC is equal to FG over GC. Okay, just like you said, it's common. All right, again, proportionality, intercept theorem. Now, what we're doing is that we are working, you said the x is equal to 10. We'll get to the answer now. We'll see now, CP. Hang on a second. Okay, so FE parallel to DG. Okay, so Nala and everybody else, when two things, so if A equals B and B equals C, we can say that A and C are equal. So because they're both equal to FG over GC, they must be equal to one another. Okay, so now our deduction, AB over BC equals ED over DC. Substitute, AB is X, BC is 15, Timothy's also getting 10, is equal to 22 over 33, cross multiply. Okay, yes. All right, so 10 would actually be the right answer. Good job. Nice, well done, Matrix. Okay, we're getting there. Okay, so I suppose in something like this, there would be probably 1 mark statement reason, 1 mark statement reason, and then another mark for the answer over there. Okay, so now let's go to something that's even a little bit more difficult. Okay, let's have a look at this one. So in the figure, we've got EHG parallel to FC. They've told us that AH over HC is 6 over 5. So let's put that in. And they've told us that AE, let's use a different color, that AE over EB is 3 over 7. So again, your starting point, all right, which triangles can you, okay, and they want us to calculate, sorry, I should have finish reading all of that. They want us to calculate BG over CG. Okay, so that's BG over there over CG like that. Okay, so in which triangles can we work, Matrix? In which triangles can we work? Can we apply our proportionality intercept theorem? AFC says a CP. AFC. I agree with you, okay? AFC, because EH is parallel to FC. Good. Okay, so a CP, that's definitely one of the triangles. AFC. Is there another triangle that we could work in, Matrix? Why can we not work in ABC? Karabo and Benedict, we cannot work in ABC. That is because in ABC, we do not have one side parallel to the third side of a triangle. So we can't work in ABC. Okay, so Chad says EBG. Sake says EBG. Good, Sake. Good, Spatle. BEG. Yes. Okay, well done, Chad. All right, so we can also work in triangle BEG. Okay, because we have this side, well, this line FC drawn parallel to the third side of the triangle. Okay, so that's always the first thing that you want to go for. Find the triangles that you're allowed to work in. So they want us to work with BG over GC. Well, we don't, what's BG over GC equal to? What's BG over GC equal to? If I had to make a proportion with BG over GC, what would I say? BG over GC equals what, Matrix? So BG over GC, so it's the entire length of the side over the little bit, it would be equal to BE.
Amen.
Yes, Timothy, go for it.
Wouldn't we say it's EG and HG over HG?
Okay, what I would say here, Timothy, is I would say that BG over GC would be equal to BE over FE. Does that make sense? So,
nope.
Okay, not a problem. Which triangle am I working in, Timothy?
We are working in triangle EG and B.
Okay, so we're working in triangle BEG. Okay. So I'm just going to highlight that for you. Okay. What I've done here, okay, is I've written the whole side. BG is the whole side.
Oh.
Okay, over the whole side. Okay.
Yeah.
Is equal to the little bit. So in other words, CG is this little bit over here. CG is there. Over this little bit. Over there.
Now
over
I see.
FE. Do you see it now? Okay. Do the rest of you see it as well? Thanks, Timothy. Good. Turn it upside down. Absolutely. Absolutely, SCP. If we turn it around, it makes sense if you rotate the triangle. Let's see if I can do that. I mean, all our numbers are going to disappear, but let's just have a look. There we go. Okay, well done. Right, so now it makes sense to us. Well, at least I hope it makes sense to you. We've rotated it. Okay, so now we've got, here's our triangle. Badly drawn by me. Okay, especially line EB. Sorry, Matrix, that was terrible. Okay, so they gave us BG over GC. BG over GC or CG is going to be equal to BE over FE, sorry. Okay. Proportionality, intercept theorem, FC parallel to EG. But now what's the problem, guys? Okay, now remember we've also got rid of all of our lengths. Let's just pop those back in here again. Okay, so AH was this one over here, that was 6. HC, that was 5. AE was 3. And EB, which is this bit over here, was equal to 7. Is that correct? So if we have a look at this proportion that we're working with, what do we know? What do we not know? Okay, well, we know what BE is, don't we? We've got that. Have we got FE? We don't. We don't have FE. So we can't work out what BG over GC is until we know what FE is. So now we're going to have to go back and go and have a look in the other triangle and say to ourselves, well, can we use the other information that we've been given to work out how long FE is? And the answer is yes. Okay, so a C pair, you had such a great idea to turn it upside down. A C pair, I want you to make me or make us a proportion with FE in it.
Ma'am, can you please repeat?
Sure, a C pair. No problem. Okay, so a C pair, we need to work out what FE is. So now I want you to make a proportion with FE so that we can calculate what FE is.
Oh, it's going to be AE over FE.
Just hold on a second. You said AE over FE.
FE is equals to AH over HC.
Okay, so let's just have a look at that. You've said AE over FE is equal to AH over HC. Excellent. Okay, perfect, a C pair. Proportionality, intercept theorem. And that's because EH is parallel to FC. Okay, and now we can go ahead and substitute, can't we? Okay, so we know that AE was equal to 3. We know that FE, well, FE is what we want, so that we'll leave that at the bottom. We know that AH is equal to 6. We know that HC is equal to 5. And now we're going to cross multiply. So that gives us 6 FE equals 15. So that means that FE is going to be equal to, well done. Okay, so 15 over 6, which is divide by 3 and get 5, divide by 3 and get 2. Yeah, 2.5, Celine, well done. Yeah, 5 over 2 or 2.5. Good job. Okay, so now we can come back here and we can substitute. We can say is equal to, remember BE they told us was 7, and FE we've calculated as 5/2. Now, this is something that we are not allowed to do, Matrix. We cannot leave a fraction as a complex fraction, all right? If we do this, we will be penalized. So we are obliged to rewrite this in the correct way. All right, remember we're working with proportions, all right? So they want us to give a ratio of BG over GC, so we need to be working with whole numbers. So in other words, what we've got is keep, flip, change, KFC, how we work with fractions. So in other words, if we have 7 divided by 5/2, that is the same as 7/1, keep the first one the same, times 2/5, which leaves us with 14/5. So we are obliged to do that with our answer. Okay, Matrix, final answer, 14/5. So BG over GC equals 14/5. Okay, how's everybody feeling? Give me some emojis. You seem to be doing really well. How do you feel? Cool, Silindile. Thanks, Cheeto. Cool, Asipe. Cool, Chad. Cool, Svelihle. Nice, Rekumaditswe. I'm glad to see you smiling. Nice, Sake. Cool, Timothy. Nice, Jaden. All right, I'm happy. Okay. All right, so we've got 2 more questions that we can have a look at here. We've still got 20 minutes. It would be nice if we could do both of these questions. What I'm going to do, though, is I'm going to go to the slightly more difficult question, all right? And that's this one, this number 10 over here. So let me just pop that into the middle of the screen. Okay, and we're going to work on this one together. There we go. All right. Okay, let's do this. So in triangle ACE, BF is parallel CE. Okay, so they didn't put in the parallel lines. So let's just draw those in first of all. Let's use purple. So BF is parallel to CE. They've also told us that BC, so that's this little bit over here, is 3/8 of AC. Interesting. Well, what exactly does that mean? What exactly does that mean for us? If they tell us that BC is 3/8 of AC, are they telling us how long AC is? What do you think, Matrix? So in other words, what they're saying to us is that if you could imagine that AC is cut into 8 equal pieces. Yes, AC being 8, quite right, Swelihle. So AC is equal to 8, all right? BC is 3 of the 8. So in other words, this is 3 over here. So what's BA? Indeed, Rekumuditswe, that's equal to 5. Nice, good job. Okay, well done. Well done. Okay, so the whole thing is 8. Now, what else have they told us? That AE is to ED is 4:3. So AE is to ED is 4:3. Okay. So once again, the question is, in which triangles can we work matrix? Identify your triangles first, right? Determine DG is to GB, fine, but which triangles can we apply proportionality intercept theorem to? Okay, so a CPAIR says we can work in ACE. I agree with you. Chad, Timothy, yes, we can work in ACE. So we can triangle ACE, lekker, because BF is parallel to CE, lovely. What other triangle can we work in? Look for another triangle matrix. ACD. No, unfortunately, we can't work in ACD, Swelithle, because we haven't got one side drawn parallel to the third side. DBF, well done, Nala. Well done, Nala. Very good. Okay, do you see that, the rest of you? Nala has identified triangle DBF. Good job. Okay, so DBF is this one over here. Again, because BF is the third side and GE would be parallel to BF. Okay, good spot, Nala. Very nice. Now, what do they actually want from us? They want DG. Yeah, it is a sneaky one. Quite right. That was very sneaky. Okay, so what do they want from us? They want GD is to GB. Very sneaky, because check that out. DG is to GB means we would have to work in triangle DBF. Okay, so if we use that as our starting point and sort of try and sort of work backwards, what is DG over GB actually equal to? So if we're in triangle DBF, like Nala said, because GD, say that again, Nala says, DE, exactly. Yes, yes, Chad. Okay, yes, Nala. Okay, is equal to DE over EF. Now, I'm just writing this down as a place for us to get started, right? We know what ED is. So we know that that is equal to 3. They've given that to us. But we do not know what FE is. So that is our starting point. Okay, that's where we need to begin. We need to begin with calculating EF. Right, so what we will do is we will come back to this information. Okay, we'll come back here once we've worked out EF. So now if we want to work out what EF is, which triangle are we working in? We want to work out what EF is. Which triangle do we need to work in? Indeed. Okay, so Chad, go for it. Make us a proportion with EF in it. Okay, so we all agree our starting point, dg over gb, is 3 over EF. If we want to start there, we can. Proportionality, intercept theorem, GE parallel to BF. Okay, so Chad says, let's just have a look at what you said here, Chad. AE over EF. AE over EF. AE over EF is equal to AB over I think you're on the right track there, Chad. Okay, so you said that AE, so the whole side over the little bit, is equal to the whole side over the little bit. So it would be AC over BC. AC, now I wrote AB, but I meant to write AC. AC, the whole thing over the little bit. BC. Okay, proportionality, intercept theorem. Okay, so everybody, can you see Chad is working in triangle ACE? Right, I'm going to explain this again. BF parallel to CE, right? What he's done is he's worked with the whole side. So AE over EF. So whole side over the little bit is going to be equal to the whole side AC over the little bit BC. Okay, remember EF is what we want. Okay, we want EF, so we're going to make EF the subject of the formula. Do we know what AE is? Yes, we do. We know that it's 4. So we've got 4 over EF is equal to AC is equal to 8. And we know that BC is equal to 3. Okay, so Silindile has already got an answer there. Silindile, we're going to see if you're right now. So that gives us what? 8EF is equal to 12. So that means that EF is going to be equal to 12 over 8. Divide by 4 and get 3. Divide by 4 and get 2. Okay, so now matrix, we can take that, this value for EF over here, and we can go and substitute it in here. Okay, so that's what I'm going to do now. So I'll write over here, DG over GB is equal to 3 over 2. All right, and remember matrix, we are not allowed to leave it as a complex fraction. Okay, so we have to simplify it. All right, so in other words, we've got 3 divided by 3 over 2, which is 3 times 2 over 3. So that would be 2. So DG over GB is actually going to be equal to 2 over 1. So just to answer our final question, DG is to GB is to 1. Yes, Karabo. Okay, 2 is to 1. How do we feel? Give me some emojis. How do you feel? Does that make sense? Everybody happy with that? Good. Nice, Karaba. Nice, Walihle. Thanks, Timothy. Thanks, Sayuri. Asipe. Okay, Silindile. All right, that's wonderful. I'm so glad that you guys are feeling confident. Do you feel that, you know, compared to where we were when we started, do you feel as though things are clearer and make more sense? You can either say yes or no. A lot more sense. Oh, good. Yes. Oh, I'm pleased to hear that. Okay, so kinda. Okay, Benedict, I know it does take a while. This is not easy. Cool, Nala. All right. So the first thing that you always want to do with these sorts of things, guys, is identify the triangles that you are working in. All right. So when they give you something like this, make sure you can work out which triangles you can apply proportionality intercept theorem to, and then go from there. All right. I don't know. We've only got 6 minutes left. I don't know if we're going to have time. Should we just try and squeeze this one in? Coco, do you think that'll be all right?
Yeah, I think that should be okay.
Okay, all right, let's try and
use their brains real quickly. We should be okay.
Yeah, okay, so let's try and squeeze this one in, and then we can really say that we've done a lot of work. Okay, so we've got DE parallel to AB, DE parallel to AB, and we've got DF, so DF parallel to AC. Okay, Asipa, yes, that's fine. We're gonna move on to that. Okay, we are going to talk about similarity. We were just talking about proportionality intercept theorem today, but we will go into similarity and proving and how similarity and proportionality go together. All right. So which triangle? So we need to prove that GB. So GB is this whole side over here. So GB is to GD is the same as GD is to GC. Okay, interesting. Well, let's start. They've given us this, right? So let's use that as a starting point. So GB over GD, GB, the whole side, over GD, which is this one over here. Which triangle are we working in? So GB is this side over here. GD is this side over there. There's a line drawn parallel to the third side of the triangle. So yes, I would say in this case that we are working in triangle BGF. What do the rest of you think? BGF. ABC? So GB over GD equals GF over GE. Proportionality intercept theorem. Okay, we worked in triangle, just so that you know, we worked in triangle BGF. So if GB over GD is GF over GE, what is GF over GE equal to? Is there anything that we could say about that? So GF over GE, GF over GE. GF over GE. What's GF over GE equal to? Which triangle are we working in now? GF over GE equals, well, if we still work in this triangle over here, it would be equal to GD, whoopsie, over GC, wouldn't it? Okay, so GF over GE equals GD over GC. Proportionality. Oh, I forgot to name the parallel lines. How bad is that? Okay, so GB, that was ED parallel to BA. ED parallel to BA. Okay, so now we've got GF over GE is equal to GD over GC. Again, proportionality, intercept theorem, and that is because DF is parallel to AC or EC. Okay.
Ma'am?
Yeah?
Isn't it that therefore GB over GD is equal to GD over GC because GF over GE is common?
Yes, exactly. Exactly. That's exactly the same thing. Okay. You've spotted it 100%. Okay. So here is our link. Okay. That's what links it together. Okay. So therefore, quite right. GB over GD will be equal to GD over GC, and then that means that we can write it as a proportion of numerator is to denominator. So GB is to GD is the same as GD is to GC. Well done, Jaden. Excellent. Well done for spotting that. Okay, so unfortunately we're 2 minutes over, but at least we managed to do that pretty quickly. Well done, Matrix. So I'm going to hand you back to Coco, but well done. Yes. I'm really, really pleased. That was wonderful work. You guys have done a great job tonight. Okay, as always, it was wonderful working with you. Thanks for your enthusiasm and for working so hard. Okay, well done.
Awesome stuff, guys. Thank you so much. You know what, Lee? I see so many new names. I can hardly keep up with everyone who's new in here. I'm seeing a Sayuri who I've never seen before, Tiasha, yes, and Chad. I've never seen you before. I assume you guys are new. Welcome. I hope you guys are enjoying being here with us. We hope to see you again on Wednesday. Invite all your friends, more of your friends, please. We'd love to see all of you guys here with us. And for I think there are about 10 kids on the live stream. So hello to everyone on the live stream as well. Thanks so much, guys, for joining us. So glad to hear that you're happy to be with us, Chad. I hope you're learning as much as you possibly can from these lessons. Thank you, Lee.
It's a pleasure.
Going into the exam, I would feel so much more assured of this particular section. So thank you very much for this. You guys need to collect all those marks in this section. Okay, I'm going to share my screen quickly. Let me see. Okay, here we are. All right, so this is our workshop. And again, guys, remember, if you want to see the whole the schedule for everything that we're going to be doing for the grade 12 workshop, you can find it on watobe.co.za. So you are welcome to go look there. All right, so here is where we are. Lesson 1, Proportionality Intercept Theorem today. And you guys are doing such a fantastic job. We are so proud of you. We're so happy. I'm so happy to have heard so many of your voices today. I think this is the most I've ever heard you guys' voices. They sound beautiful. We want to hear more. So please speak to us a lot more next time. Okay, I'm going to expect everybody to just unmute and say hi. If you want to come in like maybe a minute early or so just to say hi and chat to us, that would be great as well. Let's see if some of you would like to come join us so we can find out a little bit more about your lives. Hey, okay, so listen to Wednesday, same time, same place, this exact same Zoom link. So please don't delete it or anything. We're going to be using this exact same one again. Okay. So the homework that we're going to be looking at, if you go into Watobe and you go to the topics, we're going to look at geometry and we're going to go to proportionality theorem. I hope I've got the right one, Lee. Is it converse of the proportionality?
No, it's the one below. So it'll be proportionality theorem. And then next week it would be converse. Yeah.
Okay, so everybody scratch what I've done here. It's the one below it. We're doing proportionality theorem. So the one under.
Correct.
Okay, correct. All right, yes, this is the course schedule, everything that we're going to be doing for this workshop, and we are currently on week 2. So if you've missed anything from week 1, do not worry. It is all on our website as well. You'll be able to find it. And on our YouTube page as well. So if you go to YouTube and you'll find a playlist in there called Exam Prep Revision, and you'll be able to find everything that we've done before, catch up with us quickly, and then we can continue from there. All right, and again, last but not least, invite all your friends, please, everyone. If there's anybody else you know who you think will benefit from this, please have them join us here at Watobe so they can get as much out of this as we are. Okay, thank you so much, Lee. Thank you guys so much for joining us. That is it from our side. We are going to see you guys again on Wednesday at 5 p.m. Okay, bye-bye, everyone. You can unmute and say bye-bye. I'd love to hear your voice. Oh, I hear a question. Is there somebody here?
Yes, ma'am.
Yes, Karabo.
I have a question about the work that we did today, but it's a screenshot. So I was wondering if I can get an email so I can like forward to you so we can do it the next time.
Oh, I know what you can do, Karabo. If you can just pop that into the chat. It's me on the other side of the Watobe chat. So if you pop that in there, I'll be able to pick it up and send it to Lee for her. Okay.
Okay, no problem. Thank you.
Sure. Okay. Awesome.
Perfect. Well done, Matrix.
Thank you, guys.
Looking forward to seeing you on Thursday.
Oh, Wednesday.
Bye.
Wednesday. Sorry. Wednesday. Bye.
Bye, everyone.
Bye.
Oh, that was
Bye.
deep.